Les presento a Marcus Egg, estudiante de doctorado de la Universidad de Carolina del Norte. Nos va a dar una charla de inteligencia artificial en juegos. Va a ser en inglés, así que los que no se la juegan muy bien me van a ver qué captan y cualquier duda pues, preguntan en español. Él habla un poquito español, pero sin problema. Entonces, adelante.
Thank you. Buenos días. Yeah, as she said, Martin Zega. I'm going to talk to you about game AI. I'm going to speak in English. If you don't understand something, please stop me. You can ask questions. I'm a PhD candidate at NC State University. What that means is I'm close to finishing my PhD, and I'm doing research in games, and particularly game AI. And I focus on games that involve communication between players. Basically, how do we build AI agents that can communicate with human players in a way that is natural to them? And I do that by modeling the beliefs of human players and actions that can manipulate these beliefs. And I have my agents have cores, so they can actually work in a way that is natural for human players. I'm originally from Austria, so if you hear an accent in my English, that's where that's from. Y hablo un poco de español, preguntas, pero I probably will need some translation of technical terms. So, but we can make it work. This talk has a lot of pictures in it of different games. Doesn't mean that any of the producers of the games endorse what I'm saying. Basically, just this thing. So, why do we do games? Or why should you do games? First, the games industry is huge. They make over 100 billion in revenue each year, and it's growing. The forecast is that in the next 3 to 5 years, they will make more money than the sports industry. So, really good industry to get into. And AI becomes a more important aspect of that, as I will explain later in the talk. Also, everything we do in games has applications outside of games, or most of the things we do. And many of them are very important. I'm going to go into more details about that at the end of the talk as well. But most importantly, we do games because games are fun. So, does anyone here like games? No? Yeah? Anyone? Yeah. You? Okay. Well, I hope you know some of the games that I'm going to show you. So, let's talk about. So, when I say game AI, what most people think of first is we build some intelligent agent that plays the game with you or against you. But that's just one tiny part of what you can use AI for in the context of video games. You can also use it to generate content, because making a game is expensive. So if you have something that creates content automatically, levels or graphics or sound or whatever, that makes making the game much cheaper. So that's another thing that I'm going to talk about. But then you can also use AIs to help you balance your game, to make it more enjoyable for players. Or you can model how different players play your game to make them more engaged in your game, to make them play more, to maybe make them spend more money. And I'm also going to talk about that at the end. What I'm going to do in this talk, I'll give multiple examples from different games, and I will explain different aspects of game AI for each of these games. And it's just a selection. Of course, I cannot talk about everything that's going on in every single game. So maybe your favorite game is in here, maybe it's not. It's basically just so you get interested in game AI and you can see what kinds of things we can do there. What I'm not going to do is give you a complete guide on AI or games, because that just wouldn't be possible. And also, I'm going to talk a lot about different techniques that can be used, but I'm not going to describe them in much detail. So if you're actually interested in making a game and applying one of these things, I have some resources at the end where you can find more information, or you can just Google the terms that I basically mentioned and then figure out how that works from there. So let's start with some history. Who knows this game? A few. So this is a really old game. It's called Pac-Man, and you have these 4 ghosts that play against you, and the behavior of the ghosts is really simple. In fact, they're all basically statically programmed. The red one always tries to follow you, and I think the blue one is the one that always tries to be 4 spots ahead of you. And it's basically static, but because of these interactions between the static behaviors, it looks like they're actually collaborating and trying to like get you into a corner. Because if this one follows you and the other one goes ahead of you, then they basically have you from two sides. But it's very simple from an AI perspective. But now, or 7 years ago, we got this game, Skyrim. Anyone played this?
Yes.
Yeah. So it's a very different game because suddenly you have this huge open world. It's several hundred square kilometers, I believe. You have hundreds of non-player characters that you can interact with. You can make friends, you can make enemies. And like one of the things that I did in this game, in the very beginning I got my first axe or something, and I saw a chicken and I was like, okay, I will try this axe on the chicken, and I killed the chicken. And what happened is there were guards that were looking at me and saw that I killed the chicken from the village, and then they started chasing me. Because now I was a criminal in that town. And whenever I went back to that town, the guards would start chasing me again. So that's a very different kind of behavior than we had in Pac-Man, where everything is just statically coded. Skyrim has more. There's a dynamic story. If you play the game, you can play the story, or you can do whatever you want. Some of the parts of the story change. You get side quests. Usually, these quests have parameters. So let's say someone tells you they lost a ring in a cave, and whichever cave the ring was lost in depends on which caves you have already visited. The game wants you to see new places, so they will tell you, oh, I lost a ring in this cave that you haven't seen yet. That also leads you to meet random people that you otherwise wouldn't meet. So there's a lot of AI going on in Skyrim that tries to lead you to new places, that tries to make you explore new content, because there's just so much to explore in this game. Okay. So this was basically an overview. Past, future. Now I'm going to talk about some techniques that are actually used in games, and they range from pretty low level to somewhat a bit more high level. Let's start with another game, World of Warcraft. This is, I think the city is called Hala. And let's say you have some enemy that needs to chase you through the city. So you enter through this bridge, you leave through this other bridge, and they need to follow you. First thing you need to be able to do, or the agent needs to be able to do, is find the path. And that's really hard. You have a 3D environment, you have many obstacles, you cannot run into, like through a building, something like that. So the technique that's used, so this is an overhead view of the same city. The technique that's used is called navigation mesh. So what we do, we just put polygons over the city where there are no obstacles, and then finding a path from this bridge to this bridge is as easy as finding which of the polygons we have to go through. And each of these polygons is convex. What that means is any straight line is inside the polygon, so it doesn't have like any corners like that. So if you find a path that consists of these polygons, you can just walk in any straight line through these polygons that you want. And that way you have pathfinding for your non-player characters. Any questions? Please, if there are any questions or anything, just ask. So once we have pathfinding, we want our non-player characters to do something interesting. And Halo 2, which is a bit older, basically pioneered a technique called behavior trees, which allowed the AI programmers to compose AI behavior. So you wrote a little, I'll show you. You describe the behavior as a tree. And when we, in computer science, when we say tree, we mean something like this, of course. So let's say you want the AI, the bot, to search for something. Then you say, well, before you search, you have to find the target, and then you go to the target. To go to the target, you have to find the path with what I showed you before with the polygons, and then you move to that target. And then you have this tree, and you can use it in any place where the opponent needs to search for something. Maybe they need to search for the player, maybe they need to search for cover, maybe they need to search for teammates or a vehicle that they can climb onto or anything. So this is basically like programming. In programming, you write little functions that you can reuse everywhere. In this technique, you write little trees of AI behavior that you can reuse and make bigger trees out of them. And if you have different kinds of non-player characters, you use different kinds of these subtrees in different combinations, and that gives you different behaviors. And that makes programming AIs a lot easier because you have such high reusability. And of course, if you search for something, you might not find it, and then you fail, and then wherever this tree is in the bigger tree, maybe some other behavior takes over. If the enemy can't find you, they will go back to like doing their patrol back and forth. There are other challenges in games. This is a game called The Sims, where you control a family, or you build a house for a family basically. And the family members act autonomously, so they have to basically figure out what they do when they have some need. So for example, if one of the characters gets tired, they have to find somewhere to sleep. And the way this works in this game is, let's say you have this couch, and the couch actually is smart. The couch can broadcast information to the characters and can say like, I'm an object that you can sit on, I'm an object you can sleep on. And then if one of the Sims has a need of sleeping, they need to sleep, they will remember all the objects that told them that they can be used for sleeping and use one of them to sleep in. And basically, in a way, that's how humans work. If you want to sit down, you will basically look around, where can I sit down? Ah, there's a chair, and then I will sit down at the chair. And in the game, it's hard for the character to actually look around and figure out where they can sit. So it makes sense for the object to tell the character that this is an object that you can sit in. And it also reduces how much programming the AI programmers need to do. Because if you just write the chair, you say like, this is something you can sit in, and it just automatically works with everything that, with every agent that needs to sit down. This one, so that's obviously not from a game. There's a technique called flocking. It's basically used in every game where you see a herd of animals or a swarm of birds or a crowd of people, anything like that. It's an algorithm, a very simple algorithm actually, to simulate crowd movement. So what you want to do, you have lots of, let's say, deer. You don't want them to run into each other. So the first thing you do is you just say like, go slightly apart, so they don't run into each other. Then you want them all to face in roughly the same direction. So you basically tell every one of them rotate into the average direction of all the deer. And then, because if they just keep running apart and apart, the herd would dissolve, you tell them, well, you can go slightly closer together now. And if you just repeat these 3 steps over and over, what you get is very fluid movements of crowds. So if you have a herd of deer in any video game, it basically uses a variation of this algorithm. Yeah, so this is one of the standard things. If you ever take a game AI class, you probably learn about this or implement it at some point. Super fun to implement as well. Basically, so far, all I've talked about are games in which you can see everything, in which the agents can see almost everything. Has anyone played Hearthstone? So, to those that haven't or don't know, it's a card-based game. So each player has a deck of cards that's shuffled, and then each turn they draw a card. So you don't know what's going to happen in the future. You cannot really plan ahead for what you want to do because you don't know what's going to happen. And to actually build an AI agent for this, you need to be able to figure out how you could at least estimate what's going to happen or probabilistically simulate what's going to happen. And the technique for that is called Monte Carlo tree search. And basically what it does is it simulates many different future turns, let's say 10,000. And for each of the possible actions that it can take, it writes down the probability and the score that it gets. Let's say how much damage it does to the enemy. Then it takes all of these 10,000 simulations, and for each of them it takes the probability and the score that it gets as the expected value, and then picks the one that is the highest expected value. Sounds very simple in theory. In practice, there are many optimizations that you can take, because if you already know that something is very unlikely to happen, you might not want to simulate it, or maybe you want to explore some unusual strategies to like throw off the opponent. Or you also don't know what the opponent is going to do with your information, so you need to estimate that probabilistically or with some other algorithm. So that's basically a standard for games that involve uncertainty. Has anyone seen this game? I kind of don't think so. So it's a game called Prom Week. It's from University of California, Santa Cruz. It's a research game, so I didn't expect anyone to have seen this. And it's a very different kind of game because it simulates social interactions. Basically what you do in this game, it's the week before prom, and you're in the high school and need to find someone to go out with. And the way you do that is you can basically interact with other people. So you can go and bully that person, or you can confide in them and tell them some secrets, or you can just like be nice to them, or annoy them, or like do different social things. And each of the characters thinks something about you and thinks something about other people, and there's a whole network of social interactions, social interactions and opinions about other people. And if you do something, like let's say you bully that person will not like you as much, but also their friends will not like you as much because you just bullied their friend. Or if you're nice to them, then their friends might also like you more. And the goal of the game is, at the end of the week, you want to actually date someone of those people. So this is a really interesting game in the sense that it's one of the few games that really models social interactions well. And it has this whole network of interactions that you can manipulate. You can, each of the agents has some goals, has some desires. You can talk to them, you can manipulate those goals, help them achieve them, or hinder them in achieving those goals. Then they form opinions about you and about each other. And by interacting, you can change those opinions. You can play it online. It's actually kind of fun. So this was basically a selection of how you can use AI within video games. If there are any questions so far? Because now I'm going to talk about how you can use AI in the process of developing. You had a question?
Sí, ¿cuál podría ser una característica de característica de no jugador? Es algo así, había entendido. No game character. No game character.
Yeah, NPCs. Yeah.
What is an example?
An example for an NPC? Sorry, is that what you're asking? Un ejemplo de los.
¿Alguien ahí adelante que puede traducir?
Yeah, I can translate. It's
Thank you.
I think que eres un ejemplo de un personaje no jugador. Pues, like an example of a non-player character that he can perhaps relate to. Cualquier oponente sin algo.
Yeah, any opponent, like a dragon is a non-player character. Everything that's not a player that has some sort of behavior. So the couch would not be a non-player character because it doesn't actually do anything. But the Sims are non-player characters, or the dragons because they actually attack you, or the ghosts in Pac-Man. Yeah?
Yeah, I think.
Any other questions? Okay, then I'm going to talk about how to use AI in the process of developing games. And I will start with Diablo 3. Also 6 years old. Only 6. So in this game, for those that don't know it, it's an action role-playing game and you run through dungeons and kill monsters. And every time you play the game, the dungeon looks differently. And of course, none of the developers, the game developers at Blizzard went and built 5 million different dungeons. They just built little pieces of dungeon and rules of how you can combine them. So it's basically, and that is AI. Basically you have some set of little puzzle pieces and ways that you can put them together. Then you put them together, you get a new dungeon. So what can happen? Let's say you have a room that has a boss monster in it. And then the random dungeon that you generate puts 15 of those rooms in a row. And the players will not be very happy because they go from one room with a boss monster, the next room with a boss monster, and next room with a boss monster, and it's just very hard for them to beat the game. You kind of want to pace the game in a way to make it easier sometimes and harder other times. But because generating random dungeons is so cheap, you can just generate one, look if it is actually good quality, and if it is not, throw it away and make a new one. And that works if you are reasonably certain that you can make good dungeons often enough. And you can identify which ones are the bad ones. It's the other important one. Another game that kind of tried to do that is No Man's Sky. Has anyone played this? Did you like it?
It was interesting. It was interesting in a way.
So, yeah. So it's a space exploration game. And it has 15 quintillion planets, which is a lot. And they're all procedurally generated. They have their own plants and their own aliens and whatnot. And players were really excited because like, this is this huge universe and we can go and explore and this is really cool. And when the game came out, players were really disappointed. So 15 quintillion planets, how much is that? If every person on Earth looks at one planet per second, we would need, I think, 25 years to look at every planet, just for 1 second, without anything else. So it's a lot. And that means the developers haven't looked at all of them. So how did they make sure that each of those planets is playable in some way? Well, turns out they're kind of all the same. They are different, but they are not different enough to keep the game interesting for a long time. So people were really disappointed in the game because it boasted like such a huge variety of planets and a huge universe to explore, but then when they went from one planet to the next, they discovered after the 10th planet it's kind of not that interesting because you just keep doing the same things and they are just basically the same. So the hard problem is, the easy problem is generating 15 quintillion planets. The hard problem is, how do you make sure that those are good planets? How do you make sure that those are fun planets? If you make them too different, then it's really hard to verify that they are actually enjoyable for players. But if you make them too similar, then players are not that interested in them anymore. And this game came out 2 years ago. We're still kind of working on that. As game AI researchers, on how to make sure that something is interesting. Besides just levels and planets, we can generate many other things. We can actually generate stories. In theory. I don't think any game company does that yet, but there are researchers working on that that build more and more techniques on how to generate stories with the computer. And I mean, there are some small parts that might be generated in some games, but the dream is to have a game that gives you a completely new story every time you play it, and that story makes sense, that story is enjoyable, that story has all the qualities that you as a human reader or a human consumer of the game wants it to have. Graphics can also be generated, and there are some that are really easy, like trees. So I was going to look for a good tree. There's one over there. If you look at that, it's basically one trunk, and then there are branches, but the branches are just copies of the tree. They're just tiny trees. And then they have branches which are just copies of the, tiny copies of the larger tree. Sound is also something we can generate. But for the trees, so these are actually computer-generated trees, and they look reasonably good. And they look so good that there is a company that all they do is generate trees for game companies, but also for movies. So if you have seen the latest Star Wars movies, the trees were from that company. If you've seen Black Panther, all the trees in Wakanda were from that company. So they make trees, they make lots of trees, because it's really, I'm not going to say super easy, but it works really well. So, because trees have this nice recursive structure. And if you walk around outside and look at trees, you start noticing that after some time, that they're really self-similar, which makes them easy to automatically generate. I don't think anyone has seen this game either. It's not super popular. But it was very popular in the game AI researcher community because it's one of the few games that actually used AI to do balancing. So this is a strategy game. You build little buildings, you can build units, there's like some sort of airplane thing that can attack opponents. And what you want in such games is that none of the units is too strong. Because if one unit is just stronger than everything else, all the players will do is build that one unit, and there's no choice for the players are not interested in the game anymore, and then the game sucks. So what they did is they actually built an AI to play this game, but not just play it. The AI actually learns a strategy and tries to find different kinds of strategies. So it actually tries to exploit different types of strategies and find something that is dominant. So if there's anything that you can do in the game that is stronger than everything else, the AI will eventually find it. And then it can report that back to the game designer, and the game designer can look into, okay, this strategy is too strong, how can we tweak the numbers, how can we make some units weaker, how can we make something else stronger to make the game more balanced. And you basically just repeat this until you have a balanced game, or a game that is as balanced as you want it to be. Any questions? Anyone know Super Mario? There is a version that you can find online that's called Infinite Mario, where the game generates more and more levels for you as you play. So this is super cool, you never run out of levels. This version I don't think exists online because it's a pure research project. What they did is they added a camera that watches the player play the game. And if you get too happy with the game, that means it's too easy, so it makes the levels harder. But then if you get too angry at the game because the levels are too hard, it will make the levels easier. So that's basically a way to tailor games to your expectations, to your skills, to how you want the game to play out. If it's too easy, it's not fun. If it's too hard, it's also not fun. So they try to find the middle ground automatically. I think it's a super cool project. And I think we will see things like that going forward, maybe not with the camera, but by looking at how the player plays the game and how they are doing, you can do the balancing in some way, and that makes the game more enjoyable for players. And that's part of player modeling. How do you actually model what the player is experiencing in the game? Problem is, or yes?
I have a question. Do you know the game Flutterbird?
Yeah.
That game use AI, right, or not? Like to generate the...
I don't... Well, it uses AI to generate the levels, yes. Yeah, but I think it's static. I don't think it changes with how good you are. It's just like... I think it gets harder the longer it goes. Flappy Birds is actually an interesting example because it was one of the research examples where people build AIs for the game. But not... So it's easy if you have the exact coordinates of everything. But it's hard if you look at the picture of the frame or just of the screen and then try to build an AI that just uses the picture information. So that was one of the earliest examples of actually playing a game from the image information and not from the game information. If that makes sense.
Yes.
Yeah. So everything I talked about lives inside the game, so it has access to all coordinates, it has access to lots of internal information that you as a human don't have, because you first have to look at the picture and then estimate how far something is away from each other. But there's current research that actually tries to play games like humans by looking at the picture and then deducing everything from there, which is a lot harder. And yeah, we're going to work on that for the next couple of years, at least. Thank you, really good question. Where was I? Oh, if you want to tailor your game to how the players want it to play, there's one problem: there are different types of players. So, for example, one type of player might like to explore and run around and see what's everywhere. And another kind of player just wants to fight everything they see. Another player wants to get the highest score possible in the fastest way, so they don't really care about distractions, they just want to get to the goal. And if you want to tailor your game to these different players, first you have to identify which type of player you're dealing with. So that's something that's being looked into. Flow refers to this concept that I talked about earlier, where if the game is too hard, it's not interesting. If the game is too easy, it's also not interesting. but you actually want to make the game get harder over time, but not too fast. And if you look at Diablo, for example, it's a great example for this, where you fight some monsters and it gets harder and harder and harder, and at some point you almost cannot kill the monsters anymore. But then you find a new weapon or a new shield or something, and suddenly you can kill everything instantaneously. So the game became harder and harder and harder, and you were really frustrated, and then you find a new weapon, and suddenly it's super fun and it keeps you going, and then it becomes challenging again. But then because you know when it starts getting challenging, at some point you will get this better weapon that makes it easier again, that keeps you playing. And basically this level of how do we have difficulty grow over time is called flow. And it directly leads to player retention. If you make a game, what you want is players to play the game, and for players to keep playing the game. Especially now, in the age of free-to-play games, where you have microtransactions, you want players to play the game for many years, and basically spend money every couple of minutes. But, well, so you want players to keep playing your game. That's basically the message here. And then there are some ways that you actually can use all of this for monetization. So the goal of a game company is to make money in the end. And there are ethical ways to do that. There are also less ethical ways to do that. But every game needs some sort of income for the game company to actually keep making games. And if you can model your players, you can also figure out how they're willing to spend their money. And again, you can do this in ethical ways where you sell them things that they technically don't need, but if you make it well, then they probably want to support you. Or you can make it in an unethical way where basically they need to keep spending money because it's a lottery or something. Any questions about this part? Because now I'm going to talk about something that's not necessarily games. So I talked about how the things that we do, or how AI can be used in games, how AI can be used for game development, but now I'm going to talk about how the things that we do in game AI can be applied to things that are beyond games. Well, this is still a game, technically. It's called Philo. It's actually kind of fun to play, even though it's a bit weird. And what this is these are DNA sequences that you have to align. So you have to basically put the same colors underneath each other, and then you get the score. There's some sort of high score, and this is what the computer can generate. And if you know, or if you've heard of DNA sequencing, it's really hard to do for a computer, and it's really important in cancer research, in infectious disease research, basically in all of medical research, because you want to know which other kinds of DNA you can use for each part of the DNA strand. So by players playing this game, if they beat what the computer can do, that means they found a better match of DNA. And then that information is sent back to the medical researchers that look at the alignment that players found and that they can then use for their medical research. So technically still a game, but it actually does something that's good, that's useful. And there are other games like this. I think there's one where you look at telescope pictures and try to find new stars. And if you find some that the computers missed, then it's sent back to the astronomers that look at whatever star could be there and things like that. So there are a bunch of these things. This also is technically beyond games. Has anyone seen Westworld? It's a TV show about a Western world where people go, and these people are actually robots, and they can interact with the robots. Each of the robots follows a storyline, and the players can basically either go on a quest, like a treasure hunt, or they can just go and socialize in the town. They can go to a saloon, like typical Western things. So in a game, you always have some sort of goal. Even in Skyrim, which is technically open world, you still have some sort of story to follow, or main quest to follow. But you can expand this. You can build like a whole virtual world where players can play something, or they can just go and socialize, or they can just explore the world however they want. And this is basically very unrealistic because we're not going to have robots like this anytime soon. But making this virtually is a much more achievable goal, a goal that we might achieve much sooner. And then you have these different virtual agents that you can interact with. And then there's also something actually useful. So this is used to train firefighters. Basically, they have a virtual reality headset where they see the fire, and then they have a fire hose that's equipped with sensors, and they can practice how to extinguish fires. In this version, it doesn't use much AI, or probably not any AI, because all it does is you have a fire, you have to extinguish it the right way. But then you can extend this. How do firefighters actually operate in practice? There's a burning house, there are probably people inside, and they behave in some way. So if you can simulate the behavior of people in need realistically, you can use that for training of firefighters in a very, well, it's a cheap way, it's cheaper than actually setting a house on fire. And you can simulate a wide range of scenarios that you might not be able to do otherwise. So that's actually one of the coolest things, I think, for how to apply game techniques really outside games. But there's so many more. IBM Watson, I don't know if you've heard of this. It was a question answering system. Basically what it was built for is you ask it a question, it answers the question. But the original version was built to beat Jeopardy, which is like this TV quiz show. And the show itself relies heavily on puns, relies heavily on cultural knowledge, things like that. It's really hard to do for a computer. And IBM built Watson basically to beat Jeopardy, and then afterwards they were like, well, we have this system that can answer questions, where else could we use that? And now it's used in hospitals to give advice to nurses and doctors about like medical conditions. There is Chef Watson that can generate recipes for you, so you can basically ask it what goes well with carrots, and then it will come up with a recipe. Things like that. RoboCup is a project that started as can we build robots that can build the human world champion at soccer? And the goal was to do that by 2050. I'm not sure if that will work out, but we will see. But at some point they realized they have these soccer robots that can basically play a game. But we could also build robots that do rescue missions. Like you have a collapsed building, it's much safer to send a robot in there than to send a human in there to rescue people. And it's basically, we started with a game, it led to something else. Autonomous cars are in the news a lot lately. And some of the techniques that I showed you earlier are useful for autonomous cars, and then there are others. So for example, pathfinding. If you have an autonomous car and you want to go somewhere, you of course want it to get there, so it needs to plan a path. And it needs to avoid obstacles, and it needs to basically reason about different things. And maybe you have different kinds of behaviors for the car, one for the highway, one for like a small country road, one for the parking lot. But basically what all of video games is a giant simulation of human-computer interaction. Because in a video game you have this non-player character, and to some you can talk to, some of them are your enemies, and to make the games more enjoyable, a lot of resources are spent on making these characters more believable. And you can use these same techniques for basically everything in a computer. I don't know if any of you remember the little paperclip in Microsoft Word that was really annoying, that tried to give you hints. That was a bad example, because it didn't actually follow any useful guidelines on how humans communicate. But now, if you use the techniques that you have in video games, where you might have a very good character, a very good computer-controlled character. If you use something like that for hint giving, it should be much better for humans to actually interact with. So this is basically the last slide. I promised you some resources. So if you're interested in AI and games now, or well already before, the best recommendation I have is the book called Artificial Intelligence and Games by Georgios Yannakakis and Julian Togelius. It's on gameaibook.org, and the best part is there's a PDF download for free. And this basically explains, I think, all the things that I talked about in this talk, and more in more detail. So this is really a really good resource. And if you want to make video games, what I would recommend is starting with Unity. I don't know, has anyone played with Unity? Or?
Yeah, it's like online game, you know? Well,
so Unity is a game engine.
Yeah,
so,
I played some games,
yeah. So if you want to make your own games, it's probably the easiest way to get started, because it gives you all kinds of things, like you can load 3D models, you have predefined code for some of the AI techniques that I told you about, you can even like there's a store where you can buy more code, where you can buy more models, or there are lots of things for free in the store as well. So these two are really if you want to do AI in games and you want to get started, I would recommend these two. GDC is the Game Developers Conference. It's the largest industry conference on where game developers or actual games go and present and talk about their work as much as they can. And the board has videos of these talks. So that's also, I think the Halo 2 talk is on there and some others. AI Game Dev used to have lots of free tutorials. Now it's mostly paid, but there's still some free information on there. As is on the AI Programmers Guild, Game Programmers Guild, where basically AI game programmers congregate and exchange information. And they have a wiki with some more information. But yeah. So if any of these sounds interesting to you, I recommend you visit them. Muchas gracias. Yes, please.
Bueno, quizás salga de todos los temas de que estaban acá, pero ¿cómo está lo que es el desarrollo de torneos ya como deporte? No sé si pudiéramos imaginarnos en un futuro muy próximo ver tal vez los videojuegos en Juegos Olímpicos.
Traductor oficial, por ejemplo.
Alright.
I got like half
He's
of
asking
that.
what he thinks, probably a little off topic, what people think about video games progressing towards like sport level of tournament competition.
Oh, that's not off topic at all. You mean the actual tournaments, like the esports scene?
Yeah.
So that's actually really good for AI research because that means there's more money for us. So last year at the Dota tournament, the international, there was OpenAI had a bot that played Dota in a way. And that basically means more publicity because now the gamers are all interested in, we have all these AI researchers doing things. But also the companies themselves give more money to us. So actually it's a good thing. And for, I don't know, any of you that might be interested in working on games, that's also a good thing because that means there's more money in games now. As I said in the beginning, it's probably gonna be bigger than the sports industry soon. So it's a really good time to work in games right now. Yeah? Indianas? Yeah? Yes?
This question just came to my mind.
Sure.
I don't know if you have seen, like, when you enter into a game of free-for-all in Call of Duty, that is not online, you can generate like bots to play with you.
Mm-hmm.
How does the AI works in these bots?
So I don't know specifically about Call of Duty. My guess is it's a similar concept where you have some sort of small behaviors and then like whatever the situation calls for, they will use that behavior, like the Halo bots basically. I don't know, where exactly is your question going?
Like, what is like the tree that they follow? Because
That's probably not public information. So the other problem is, much of the information that I presented is what's publicly known, but there's so much that the game developers don't tell anyone. So how exactly the bots work, they won't tell anyone because then other people will steal it.
Okay, thanks.
I have a question.
Yeah.
Well, you know, like a lot of people always prefer to play with humans, you know, like instead of AI. So I think that the AI wants to be like a human level, you know, like be as intelligent as humans.
Yeah, that is true.
Yeah.
And so one of the things, I talked about the Dota thing earlier, right? And that was just 1 versus 1, because making the AI play teams is still really hard. And then if you, as a human, play on a team and there's a bot, that's really frustrating because the bot doesn't play well with humans. And if you play against bots, they are probably really bad because the game is really hard. So yeah, that's one of the things we are still working on. And it's a hard problem.
Yeah, how long do you think it will take, you know, to reach that level? You know?
Last year, I talked to some researchers that basically said 2 years, and I think that's a bit too optimistic.
Yeah.
Yeah, so my belief is like 5 years, but a lot can happen, so don't quote me on that.
Okay. Thank you.
Yeah. Any other questions?
Where is your favorite game?
At the moment, I mostly play Smite.
Smite.
Yeah. So I think that's my favorite. I'm also trying to finish my PhD, so I don't have that much time to play at the moment. It's a bit of a drawback. My actual research is about board games. So I use Hamabi, One Night Ultimate Werewolf, which are games where you communicate with other people, and I implement them on PCs, and then I build AI agents that play those games. So I really like them, but it's my work. That makes sense. What's your favorite game?
I think Zelda Twilight Princess. I'm a huge fan.
Okay, very nice.
And I am also a huge fan of board games.
Yeah?
Yes.
Cool.
What would you say is the most interesting AI use that you've seen perhaps in the past year or two?
I'm biased. So the AI use, let's clarify. Do you mean in the actual game or in the research? Okay. Okay, that's a harder question, because in the research I could tell you more. In the game,
I mean, if you have an interesting example in theory, that's also fine.
I don't.
I mean, that's fine also. If there's something interesting in research, that's fine too. Just whatever.
So,
off the top of your head.
Yeah, so in research, what comes to mind is I talked about narrative generation earlier, and there are just so many researchers working on story generation. And I think it's a really cool thing to read stories that come out of a computer. But what happens very often is that you make some assumption that the computer doesn't have. So if you make like a story about a knight and the dragon and the princess or something, I saw a story where the princess was kidnapped by the dragon, and the goal for the story was for the princess to be rescued. So the princess ate the dragon, and then the princess was rescued. And it's just, I find it very interesting to see these things that you as a human just assume that the computer doesn't know. Problem is there are still a lot more things to do for story generation, because such stories might not always make sense, but it's just interesting. Anything else? You can also talk to me after or something. So.
Bueno, thank you very much.
Yeah, thank you.
Gracias.